going to do 55 and 56 together because I think that that will be useful to see. So here we have W equal the set of all f belonging to all the continuous functions such that f of some random number is equal to 0. Here we have, W prime is equal to the set of all f belonging to the continuous functions such that f of some other number equals 1. Is this a subspace? 55 will be a subspace, and I'm going to use theorem 45 to do it. So I'm going to let z of x equals this be the 0 function. And when I say this specifically, we know that the constant function 0 is the 0 function of z, but I'm just, the only thing I've done is I've said let z be the name of it. Because then what I can say is z of 0.62, well, what is it? Well, it's always 0 for everything. So z belongs to w. So that's the first thing I need to check. Is the 0 function, the constant function in there? How do I tell? Well, I plug in 0.62. If I get 0 out, I'm done. Well, it doesn't matter what I plug in, I'm going to get 0. So in particular, if I plug in 0.62, I'm going to get 0. So the 0 function is in w. Let f and g belong to w. I'm going to show that their sum is also in there. Then, why haven't I take their sum? Well, is it in w? The only way to tell is I can plug in it. I need to plug in 0.62 into there. And when I do that, what does this mean? The sum of two functions just means the sum of these two functions. These two are in w, which means that they have the property that when you plug in 0.62, you get 0. So what I know is f plus g belongs to w. And then finally, I'm going to check to see if it's closer to scalar multiplication. Let a be a scalar. Then, is a times f in w? Well, I don't know. The way I check those, I can plug in 0.62 and see what happens. That's equal to a times f of 0.62. Do I know what f of 0.62 is? Yes, because f is in w. And w has the property that anything in it, when you plug in 0.62, you get 0. A times 0 equals 0. So AF belongs to W. So W is a subspace by theorem 45. Let's contrast this over here. I'm going to show you 3 different ways that why W prime is not in there. So W prime is not a subspace. You only need one of these. So either the 0 function of 0.62, or 0.23, sorry, because we're working with this now, is equal to 0, which is not equal to 1. So z is not in W prime, so W prime is not a subspace. That would be a perfectly good proof to show that this is not a subspace. If you don't like that, you could do this instead. Let's see. How about f of x equals 1 for all x belongs to W prime, since f of 0.23 is equal to, what is it? It's equal to 1, because I've defined it to be 1 for all of them. But if I add f to itself, is that going to be in W prime? Well, we're going to see it's not. The way to tell if it's in W prime is I plug in 0.23. That's equal to f of 0.23 plus f of 0.23. Well, what's f of 0.23? It's equal to 1. Because everything's equal to 1. It's always equal to 1. It's a constant function. equals 2, which is not equal to 1. So 1 plus 1 is not equal to 2. So it is not closure addition. So not a subspace. Or you could do, I'm going to use the same function here. 2f, is that in here? Well, no, because if I plug in 0.23, I'm going to get 2 times f of 0.23 equals 2 times 1 equals 2, which is not equal to 1. I need it to be 1. So therefore, it's not closing the scalars. So any one of these 3 is enough. So to show something is not a subspace, you just need to give me one of these 3. To show it is a subspace, you need to give me all of those 3. So this thing, 55, is a subspace. 56, not a subspace.